Hi, we are the bicycle-driven pump design team, Group 2. I'm Adam Finck.
I'm Andrew Ledbetter.
And I'm John McSpadden.
First, we'd like to go over the background information on the problem at hand. One of our classmates' aunts needs to get water from a rain barrel near her barn to her garden 100 feet away. Her current solution is to carry buckets of water the entire distance. As you can imagine, this is very time-consuming and exhausting. She wants a better way to transport the water using only human power. The concept must transport approximately 75 to 100 gallons of water to the 40-foot by 20-foot garden. And finally, it must supply sufficient water pressure to allow for adequate watering. Luckily, as you can see, the garden is described as slightly downhill from the house, which did play into our design rationale. Now that you understand the problem, John is going to explain our concept selection rationale.
For our selected concept and rationale, we decided to go with a washing machine pump that is mounted to a wooden base. This wooden base was then attached to a bicycle trainer, and attached to the rear wheel of the bicycle. The pump was run with a sprocket that is turned by pedaling the wheel of the bicycle and attached with a bike train. We decided to go with a washing machine drain pump because it was inexpensive, operated at a relatively low pressure, and can move a high volume of water. We also figured that we could achieve the RPM range needed to operate this pump. We went with a bicycle trainer because it was portable and stable, and it was compatible with most bicycles, which was important to our design.
This is the video clip shown in section 6.4 that shows the functioning prototype. The performance metrics that we measured include the gear ratio from the pedals to the rear sprocket of the bicycle to the sprocket on the pump shaft to be almost 12 to 1, which means that when the user was cycling at a comfortable pace of 80 RPM, the pump was operating at a speed of 942 RPM. We measured the volumetric flow rate to be nearly 3 gallons per minute. The pump generated a pressure of 9 feet of water. When functioning with sprinklers, the wavy sprinkler covered or watered an area of about 10 by 12 feet, and the rotating sprinkler watered an area of a 14 diameter circle. In the future, there are a couple of things we would like to do to improve our design. As you could see, our pump needed an initial positive head in order to pump any water. In the future, we would like to have a pump that can generate more pressure and won't need this initial positive head, so that we could pump water uphill rather than just slightly downhill. We would also like to waterproof the design for durability and make it out of something more durable than wood. We would also like to design a more permanent base that would completely replace the bicycle trainer, so that the pump and the trainer would just be one part to attach to the bicycle, which would dramatically help reduce the cost and the setup time. And that is all we have. Thank you for listening.